Welcome back. This is video 2 for the strategic design notes. To begin with, we're going to talk about how to make a cost-benefit analysis. So this is broken down into tasks and builds. Tasks are things that you need to that your robot needs to do, and builds are things that you need to build on your robot. All right, so for the tasks, you want to make a list of everything your robot needs to do. So what you want to do is you want to give each of these tasks a rank between 1 and 100. Where 100 is a must-do. So 100 means that this task, you must do it. And 1 is a task that is not that important. Going back through your list, you want to take each task and then give it a second ranking. Where this time 100 is something that's very hard to do. So it's a task that's the hardest to do, and 1 is a task that's easiest to do. Yeah. What you want to do then is find the benefit, or the ratio of benefit to cost for each task. And then we can use this ratio to make decisions on which tasks we need to go after. The higher the ratio, the more optimal. So if something is a 100 where you must complete that task, and it's the easiest thing to do, it'd be 100 over 1. The ratio would be 100 to 1. It'd be something that you absolutely have to do. But if something's not important and it's really hard to do, it would be 1 to 100, or 1 divided by 100. That would be something that you would not try to go after that. Now for the builds. First off, make a list of everything you need to build. So that could be, any kind of scissor lifts, ball accumulators, ball launchers, anything. Everything that you have to build, you have to give it a rank. Where 100 is something that you must build. A chassis should always be 100. 1 will be not so important. So a flamethrower would be a 1. You would then want to give each build a second ranking. Where this time 100 means it's hardest to build. And 1 is the easiest to build. And then once again, we want to find the ratio of benefit to cost. And you want to do this for each thing you want to build, especially if you have multiple designs for the ball launcher or multiple designs for a accumulator or whatever. And again, the higher the ratio, the more optimal. A common error is that um, it's to underestimate difficulty to complete a task or a build. So always guess high. Always assume that something's harder to do than what it actually is. All right, next thing I want to talk about is the engineering design process. I found, I think on MIT, a YouTube video they put together, a 5-step engineering design process, which I think makes things really nice. You want to observe, then brainstorm, then compare, make, and then repeat. So observe. Your observations are based off of what's needed to win. And to do that, you need to understand your problem. What is it that you actually have to do? Once you've done this, this will help you to define your problem. So that means, the solution should be able to do this, this, and that. The next step is to brainstorm. So this is where you want to create ideas. Now in this, you want to do your research. What have other teams done that they found successful? And also, you want to be able to explain what your design should do. All right. The next part comes your compare. This is where you work with your team to choose the best design. The fourth step is the make. So this is where you build a prototype. Now, notice I say prototype with the design. Do not try to prototype the entire robot all at once. Just prototype individual components. Then you want to test it. Now, in a test, you want to create an independent, dependent, and controls. And then you want to figure out, does this design work? If you have time, you will want to build multiple prototypes. That way you can compare different types of designs. It'll also help you find out what works best. And finally, you want to repeat. This is called iteration. So you're going to iterate. You're going to do this over and over and over again. Imagine if they would have stopped after the iPhone 1. I mean, if they would have said, oh, this is good enough, and finished, we wouldn't have the amazing devices that we have today. So it's very important that an engineer continues with the process, to continues to go through it over and over and over again until they are happy with what they have designed. That finishes this unit's notes.